Okay, my friends, so today we will be covering the definition, we'll be covering various definitions. We'll work through definition of a square root, and then through, and working out simplifying radical expressions, okay? So basics of radical things, okay? So the first thing we'll cover is the square root. And a square root is defined as follows. B is a square root of A, assuming, for our purposes, real numbers. If and only if, definition always if and only if, B squared is equal to A. That's it, okay? Let's go like a second root if you want to be like that, all right? So, for example, negative 8 squared is equal to 64. Negative 8 is a square root of 64. Similarly, positive 8 squared is also equal to 64. So positive 8 is also a square root of 64. Okay, pretty straightforward. Let's do another example. X squared is a square root of x to the fourth, because x squared is equal to x to the fourth. Do another one. K to the seventh is a square root. Sometimes you'll see me write it as this, okay, of k to the 14th, because k to the 7th squared is equal to k to the 14th. That's it. Now, of course, right, notation. Oh no. Notationally, right, I would probably not write it as what is the square root of 7. That would be silly, right? Notation-wise, I will write it as 2 root, I don't know, 49. So I'm asking for the square root of 49, which is what? If you told me it's positive 7, I agree. But sometimes, and actually usually, you won't see me write it like this though. Usually, you'll see me write it like this, where there's no number here, okay? That means square root for short, because that's the most common one. Okay, now my first grade scope question for you is as follows. What is the square root or roots of 0, okay? Okay. Oh, as a side note, let's make the distinction. This is called the positive or principal square root, and this is called the negative square root, okay? So let's do another problem. Let's do a discussion, actually, and I want your answer on Gradescope. Can you have a square root of negative 64? That is to say, can I solve for this? If yes, why and give. If no, justify. Okay? In particular, we want, can you have a real square root? So like 7, 15, 35. Okay. Of course, you can also do other fun things, right? You can say, oh, well, I can say the square root of 36 over 49. We know that this can be written like this over this, because it could be positive 6/7. So now we're going to expand our definition, okay? And we're going to talk about the nth root, okay? Of some number, okay? So we can write this as the definition. B is an nth root of A if and only if B to the power of n is equal to A. So let's do some examples. 5 is the third, which will also come here as cube, okay? So 2 is squared, 3 is cubed, okay? 5 is the third root of 125, okay? Another example is negative 3, no, that's too positive. Positive 3 is the third or cube root of 27, okay? No. 2 is the fourth root of what number? Okay? I want you to tell me that on Gradescope. All right. My next Gradescope question for you is, can you have a cube root of negative 125? Follow up, can you have a cube root of any negative number? Whether or not the number is perfect, like a perfect root, like 5, 1/3, whatever, is a different can of worms, right? It could be an ugly decimal and that's still valid, okay? So the question is, can you have a cube root of any negative number? All right? The next question I want to ask is, can you have an even root of a negative number? So an even root is like the second or a square root or a fourth root or an eighth root, so forth. And the second, or the follow-up as well, is, can you have an odd root of a negative number? If yes, why? If no, why? Okay. And can it be any even number? Can it be any odd number? Okay. A notation thing we want to keep in mind is as follows, okay? So the square root is written like this, or like this, right? So what if I want like the third root, or the seventh root, or the 10th root, right? You would write it as that, where the n lives right here, okay? And let's talk about the pieces of this, okay? The inside is going to, is called the radicand. And that number, that n on the outside, is called the index, okay? Okay, and one more very important note, okay? The root of a variable expression so, for example, if you have the third root of x cubed, right? What to the power of 3 gives you x cubed? Why, it's x to the first. Nothing weird here. Now suppose I say, what is the third root of negative x cubed, right? That is to say, what to the power of 3 gives you negative x cubed? Your solution should be negative x to the first. No problem here. If I put a positive sign, that's fine too, for that first one. But suppose I give you, what is the square root of x squared, right? What you want is the principal root. You want the positive root, okay? So you want your final answer to be, well, what squared gives you x squared? Positive or negative x, technically, right? So what you're going to want is the absolute value of x. You want the positive, okay? The reason why this is relevant is because, let's say I give you, ooh, what the heck happened here? Let's say I give you, oh, I want you to solve for the square root, I'll put the 2 for now, x plus 2 squared, right? Well, hypothetically, you might be tempted to write this as x plus 2 and negative x plus 2, right? The problem is, you're not actually allowed to have a negative sign inside your radical. Or let me be very specific, you're not allowed to have negative values inside of your radical, okay? So really what you want is you want to say, I don't actually want any of these. I want the absolute value of x plus 2 and whatever comes from there, okay? For some circumstances, you might be able to get away with it, nothing bad happens, but for a lot of circumstances, bad things start happening. You start getting solutions that shouldn't be there. You start forgetting to check solutions, a whole mess, okay? So you want this. All right, my friends? Okay, so now let's start talking about technically 6.3, okay? Technically 6.3. We know that b to the power of n is equal to a means that the nth root of a is equal to b, right? We know this is fine, right? But if we can write it as an exponent, we should, on this side, we should be able to write this as an exponent as well, right? Let's talk about that. Let's figure out what that exponent can do. Let's do an example, shall we? Let's say I tell you that b squared is equal to a to the first, right? That means we know that if we square root both sides, a to the first square root, like that, right? Okay, nothing weird here. This is, you know, pretty standard, run-of-the-mill. But what can we write, or how can we write the square root of a to the first, or just the square root of a, as an exponent, right? Well, how did we get here? Hear me out. We know that the second root of b squared is equal to the second root of a to the first, right? We know a to the first can be written as some exponent of a, so a to the something, right? Then we can say, let 2 root a equal a to some k, okay? That means we can write our equality as 2 root b squared is equal to 2 a to the first, which is equal to a to the k. How did we get here? We got here by square rooting everybody, right? Okay, square it back. If we square it back, we'll find, we'll write it like this. I know it's going to be a little bit tedious, which is equal to this and this is the important part here, my friends, which is equal to this. Oops. Okay, hear me out, hear me out. These just get turned back to here, right? Sorry. Get turned back to here, right? This is just going to give you b squared, the inside, right? Because these two cancel out, is equal to a to the first, is equal to, here's the interesting part. What's k, a to the k squared, right? This is the same as saying a to the k times a to the k, right? A to the first must then be equal to a to the 2k. Now, my friends, if you don't know how I got there, please review your exponent rules, okay? If you know how I got here, stick with me. A is equal to A, you would agree, right? Like 7 is equal to 7, 30 is equal to 30, whatever. If I'm establishing that this is equal to this, right? And I'm establishing this whole piece is equal to this whole piece, right? That means I did the same thing on both sides to the same value. All that is to say, we didn't change the value of A. And whatever we did, a to the first, is the same as a to the 2k, right? What must k equal so that a to the 2 times k is equal to a to the first? If you say k must equal 1/2, you are absolutely right. The reason is because you get, a to the first is equal to a to the 2 times 1/2. 2 times 1/2 is 1, right? And all of a sudden we realize the square root of a to the first, which is the square root of a, if you don't want to be pedantic, is equal to a to the 1/2. Magical. Okay, let's do another one. Suppose I ask, what is the cube root of a to the first equal to as an exponent? Ready? You know this is true. Well, cube both sides to get rid of this piece. So we know what we're looking at, right? If you cube both sides, you raise everything to the power of 3, you get a to the first is equal to a to the 3k. Again, bases are the same. I say that this expression is equal to this expression, which means 1 must equal 3k. Again, this only applies when the bases are the same and I'm saying both sides are equal, okay? 1 is equal to 3k, means k must equal 1/3, which means you have the cube root of a is equal to a to the 1/3. Okay, so grade scope question. What is k if the nth root of a to the first is equal to a to the k? Justify. Similarly, what is k if the nth root of a to the j is equal to k, a to the k? All right? Go crazy. That's the problem, okay? Now, the reason why this is interesting is because you can start doing a lot of really weird stuff. Start asking questions like, let's see something interesting. let's say I ask, what is the fourth root of 81 x to the fourth y to the eighth all over 16? Okay? Hear me out. You turn everything into what? Into a fraction. This is the same as saying 81 x to the fourth y to the eighth all over 16 is equal to, or to the 1/4. And then we know how this works, right? This is the same as saying 81 times 16 to the -1 times x to the fourth times y to the eighth to the 1/4. Wait a minute. We know that, let's say, a to the j, b to the k to the n, right, is equal to a to the j times n, b to the k times n. You can distribute as long as you're multiplying, right? Or as long as the whole thing, as long as the inside is multiplication and the outside is exponentiation, right? Oh, and then you can do some weird stuff like 81 the 1/4 times 16 to the -1 to the 1/4 times x to the fourth to the 1/4 times y to the eighth to the 1/4. And all of a sudden you can simplify all these things and all your problems go away. Isn't that cool? Okay? Now, one more thing before I set you guys free, okay? If we know what we know about rational exponents, that's what they're called, rational exponents. If you know that the nth root of a is equal to a to the 1/n, and we know that, right? And we know that ab to the k is equal to a to the k, b to the k. What can you say about the nth root of ab? I want you guys to separate a and b, and I want you to turn them into, I want you to separate a and b. Can you do that? And can you write it as an exponent, or as stuff with exponents and stuff with radicals? Okay, now let's be a little pedantic, all right? Oh, pedantic side note, we do want n to be a positive integer. Okay, no negative numbers.